Hi, and welcome to question 5 of the Leaving Cert Ordinary Level, Paper 2 from 2025. So we get stuck in. This question is kind of around trigonometry / geometry. This question 5 part A is worth 10 marks, and it says that J and K, so J and K are two parallel lines. So we've been given some information here, as shown in the diagram below. The size of some angles are shown, so it intersects with other lines. We're not given any labeling. And we're asked to find the size of the angle A, B, and C. Now I know that there's a triangle here, and that all three angles will add to 180. I see down here there's a different triangle. Okay, again, all three sides will add to 180. But ultimately, and the orientation is kind of off, I have a transversal crossing a set of parallel lines, and certain rules come into play, or certain objective statements. And one is that these opposite angles are equal. So if I'm looking here to find the angles ABC, and I could approach it here that this gives a straight line of 180. So if this is 60 this far, it's 120 left over to get to the 180. And then it's the same idea here. If you can kind of spatially orientate it, that's 180. So 120 from 180 gives that 60. Okay. Now, or just rely on the statement that A is equal to 60. Why? Because of opposite angles. Now let's focus on B. And now that I know that this is 60, B is pretty easy. Okay. If I add 75 and 60, I'll get 135. 135 from 180 leaves me with 45. So B would be equal to 45 degrees. Why? Because all three angles of that triangle add to 180. And since we know two of them, we can subtract from 180 to find the other angle. Now we're looking at C, and because we found this 120 earlier, all corresponding angles, if you move this parallel line down, it would fall exactly on the line K, which means this angle would be the same here. Now we know that 120 plus 40 is 160. 160 from 180 leaves me with 20. Again, because straight lines have angle 180, and there's 180 degrees in the triangle. Okay, right. Not a bad question. Good amount of marks if you know that terminology, but you probably could guess that 60. Maybe then you'd remember that there's 180 in a thing. This might be a little bit more tricky with the corresponding angles, but it's doable. Now, part B, part 1, it's only a 5 marker across a D scale, so we can pick up some marks here. Let's be careful to read the question. The diagram below shows the isosceles triangle ABC. Now, an isosceles is a special situation in geometry. It means that the two sides are of equal length. Now, an equilateral, all three sides are equal length. Now, there's a very strong connection between the size of, or the length of a side, and the size of the angle opposite. So if this is 9, this might have an angle of, I was going to say 50. Okay. If this is also 9, this will have the same angle, which in this example will be 50. Now I don't know what those angles are, but the sides opposite, the angles opposite sides in an isosceles are equal. Okay. Hope I've said that right. And it says the length of AB, and these bars mean length of. The length of AB is equal to the length of AC. So just stating what they've said in more direct language. If this is 9, this is 9. Now D is the midpoint of BC. Okay, so this line dropping down, that's halfway. So if this is 5, well then this is 5. This is the midpoint. And it says AD is perpendicular to BC, which tells me that there's two 90-degree angles here, which means I have 3 triangles, an isosceles, but I also have 2 equal right-angle triangles. And it says AB is 9, BD is 5, so that's on the diagram, so it's all good. Part 1 then says, use the theorem of Pythagoras to work out the distance from A to D, that is, find the length of AD. Okay, so in essence, we're trying to find this side here. Now, I would suggest always redrawing the triangle. That pilot diagram could get you the low partial of 2, okay? And if you realize that Pythagoras' theorem is given to you, okay, so I've redrawn the triangle here. I've written out Pythagoras' theorem as given in the maths tables. And then I have to realize that this 9 is the side C. The square of the hypotenuse is equal to the sum of the squares of the other two sides. Okay, that's a fundamental thing in maths, provable by many ways. So if I go on to my inputs, so the C value is 9, the longest side is always the C values, which has to be by definition across from the biggest angle, which is 90 degrees. The other two sides I can call them whatever I want. I'm just going to call A is I don't know, that's this side. B is the side I'm given, which is 5. This equation has 3 unknowns. I know 2 of the 3 things, therefore there's only 1 unknown. This is solvable. So we just do it. I substitute my numbers instead of the letter, okay, making sure I don't make a mistake, and I'm going to do it in brackets. Then I can square them. Okay, 9 squared is 9 times 9, which is 81. 5 squared is 5 times 5, which is 25. Now I've got an equation of 1 unknown. I'm going to bring the 25 across. It was added on the right, it'll be subtracted on the left. I'm going to do that little sum. 81 take away 25 is 56. I have to remember, and this is why it's so important to keep writing the unknown, this is some number squared gives 56. Now, I may be able to guess it, but if I bring the square across, it'll turn into its opposite on the other side. The opposite of a square is a square root. Now throw that through your calculator, or you might know, well actually I don't know the answer. I thought it's 54. But the square root of 56 comes out as 7.483. Now they say round that to 1 decimal place. Should have given me a hint it wasn't going to be a round number. Actually my answer's wrong. Give your answer correct to 1 decimal place. 7.48 would round to give 7.5. I include the units there just to be sure, so I should amend that answer there. Don't know what I was doing. 7.5 is the answer. Now, part 2 then, which is surprisingly worth 15 marks. It's a huge chunk of the exam in comparison. It says show that the triangles ABD, so ABD is equal to ACD. Okay, sorry, show that all the triangles ABD, ACD are congruent. Now, congruency is a special thing. They're not similar, they are the same. So you can have similar triangles, kind of like, same angles, but different lengths of sides. Like one is larger than the other or smaller than the other. But congruent means they have to be exactly equal. And you need to have a reason for that, usually 3 reasons. I'm going to get stuck in. There's maybe multiple reasons here. So it says, give a reason for any statement you make. So the first thing I'm going to say is, and put the diagram in, this is the length 7.48. And actually, okay, they're isosceles. So that means that this AB is equal to AC. Why? Because they're isosceles. Okay. Then the next thing is they have a common side. AD is the same for both triangles. So AD is equal to AD because it's the same side. It's pretty obvious when you have it said out like that. The last one is the angle ADB. So this angle here is equal to this angle here, because we're told they're perpendicular. They're both 90 degrees. Okay, I shouldn't say same angle. They're both 90 degrees. So these two sides are equal. These two sides are equal. These two angles are equal. So we've proved it by side, angle, side. Okay. Now there's any number of ways of going at that. There may be other things that are similar about it that can prove congruency, but you have to have 3 things that are the same on both triangles to prove congruency. So it's a huge chunk of marks though. It doesn't seem to me to be overly hard, although the language of congruency can be off-putting. It's always been off-putting for me. Right, so that's question 5. And as always, if you want a copy of these notes, send me an email to shanetroy@gmail.com. Like and subscribe to get access to more playlists. Best of luck.